Welcome to my first YouTube video, and let me show you how I made these custom PCBs for my Iron Man suits. For this video, we're first going to need to download Fusion 360. For those who know what Fusion 360 is, it's a 3D design software, which also in it has attached Eagle, which is the PCB designing software. You can download Eagle separately, but when I tried to do it, it just would never open. I probably downloaded the wrong version, so if you don't want to download Fusion, you want to attempt Eagle, go for it. But for this, I'm going to show you how to do it in Fusion 360. So we're going to first open Fusion 360. I'm going to leave a link down in the description for this exact screen that I'm on. And we're just going to be selecting Adobe Fusion for personal use. So this comes up, I'm deleting that. So this is where your email's going to go, if you have one. So I've already got one, but I'm going to attempt to do my best to show you how to create an account. You're just going to create an account and put all your details in and all of this hoo-ha. I don't know how. Okay, give me 2 minutes. Okay, so after you put all your special details in, you'll be met with this screen. At least I hope you are. This is where I got to. Download and install Fusion for personal use. So you're just going to download this, and then we're going to cut to being in Fusion. Alright, so when we open Fusion 360, we're going to be met with this screen, but we will want to go to the top left hand corner and select File. In File, we're going to select New Electronics Design. So this is where we're going to design the PCB, which will allow us to make our schematic and then the PCB. We won't be selecting New Electronics Library. This is more for if you want to make a component, such as like an accelerometer or an Arduino Nano, but there's kind of no point for these, seeing that they're already on the internet for free. So, and I also don't know how to do it. So then we're going to select New Schematic. So this is where all the wiring and the parts will be put together before we hardwire it into our board and then get it manufactured. So once we're here, we're going to first also want to take our drawing that we've already drawn before, and we're going to figure out what we need, and then we're going to figure out how each part's going to be wired. So from my drawing, I've got an Arduino Nano because we're basing it off this helmet that I've already built. This is my helmet PCB that goes now in all my helmets. It's compact, small, it's easy to use, it's labeled nicely. So the first part we're going to need, the Arduino Nano. So after we search for Nano, we're going to select the SparkFun. Now, I don't remember if this comes default into the Fusion libraries, but if it doesn't, you just want to search for Eagle. So Eagle is the software in Fusion 360, but we're going to first want to find the schematic for an Arduino Nano from SparkFun. Now these people from SparkFun have basically made every electronic we're going to need, so if it's not already uploaded, but mine is, I apologize for that. I can't remember what I did. But after you've Google searched for that, just simply Google search for whatever it is. I'll also try and leave a link down in the description so that you can hopefully make your lives easier. So once we've picked out the Nano, we're just going to place it in, left click, right click, whatever it is, and now we've got our Nano. So basically all we're ever going to need is JST connectors. So they're the little pins that we can just plug in and pull out, so plug and play. So even if you've got like a servo motor or a JST connect, like a limiter switch, I'm messing up my words today, it's all just going to be connected anyway by a JST connector. So I made this mistake at the start by thinking I needed servo motors and limiter switches and cosplay LED eyes, but you just need JST connectors. So they're called B3B. Now I also can't remember if this has been uploaded. I think they have, because these are the ones. So B3B is the 3-pin JST connector, so the one we're going to use for servo motors, and B2B is the JST connectors for 2 pins, so the eyes, power, limiter switch. Don't question why they're called B3B and B2B. I don't know, but I also don't want to question it. Once we drag and drop this in, we're going to want to select 2 servo motors. So we're obviously going to need one left and right servo, so we're going to put in 2. Then we're also going to proceed to search for B2B. In here we're just going to select the first option, and we're also going to need, how many are we going to need? We'll need 2 for the eyes, 1 for the 4. We're going to need 4 B2Bs, 3 and 4. And at this point it really doesn't matter how many, like the organization of this, because it all gets modeled up in the next slide. Okay, so we're going to then put in all our wiring. So net is what we're going to want to be picking. This wire is just a wire to connect bits to bits. So the way that I like to assemble these is make number 1 your ground. Now this just makes it super simple, so when you see the number 1 you think ground instantly, because the ground has to be on every single part. I like to make number 2 the power, just because, I don't know, power and ground seem like they should be friends. And number 3 I make as the signal, so anything that needs a signal, such as the servo motors. If we take from number 1 with our net, we're just going to zoom into this and then left click on to this, and then we're just going to click around, and every time that I have made a joint, this is a left click, and then we're going to select ground. Now that's wired up, so we can then take the second servo motor and then take one and join it together. Now when you see this little circle, that means that these wires are connected, so it's like soldering 2 of these negative wires together, and then it's being put into the board. So if you've accidentally taken a positive, for example, and then accidentally connected to the negative, just remember, Control Z, take it back and then restart. It does kind of suck, but we can't be wiring positives and negatives because it might go boom. Okay, and then after that's done, we are going to want to go on to the power. So we're going to take number 2, and we're going to control all the way up into the VIN. So the VIN is our power on our Arduino Nano, and connect those. So those 2 are now connected. Now I like to make the servos in pins 9 and 10. I don't know why. I think this is mostly because Crashworks 3D codes it this way. But we're just going to take this servo and bring it down and then up and in. So when we also look at these, the numbers that start with the D's, they're the correct pins. The labelled ones on the outer edges, such as 2, 1, 5, 6, 7, 8, 9, those are just the pin allocations from like modelling this. It's not anything to do with the board. The ones you want to be looking for are the what do you call them? Allocated ones. So D9 is where I'm going to plug this servo in, so pin 12. And then for the other servo, I'm going to go down and around and plug this into D10. Now the thing is, you can't be crossing over these pins or otherwise it does join. So you do have to go down and around, up and then back in. It's a little bit of extra work, but it also does make everything a lot neater. Not that we're going to see this ever again, but hey. Now let's make the power. So we'll just make our top B2B our power. So we'll take number 1, go up and then in. Actually, I'm going to redo that. So, whoops. Okay, we're back together. We're going to take pin 1, run it down, around, into the ground. And now we're going to take pin 2, run it up, across, over and into the VIN. Now you can see where I've joined it right here. Because there's no circle, it does not mean these wires are connected. You definitely actually have to click the corner of these things. So this is a safe wiring. There is no problems here. Okay, let's make the next one our cosplay LED eyes. So we're going to take number 1, again, run it up and connect it in. So I'm going to click on this joint. Circle, meaning we're connected. And I'm also going to do the exact same for this other cosplay eye, and connected. So now all our negatives are connected. We can also go ahead and do this the same at the bottom for our limiter switch, and now that's connected. So now we're just going to run these wires in. So I'm going to take this second one, the next available one, just going to run this into pin 5 or D2, so this will be our limiter switch. Then I'm going to take this next thing, plug it up, and put it in D3, makes sense, and this last one into D4. And there you have it. That is everything wired up. So now let's get on to making the actual thing. Okay, so now we're going to switch to the design. So in this top left hand corner, this little guy, switch to PCB document, click on that. So now that takes us to this screen. So all our components are here in this bottom left hand corner, and you can see it's a jumbled mess. So that's why I said don't bother trying to allocate everything and make it fancy. So you're going to want to highlight this, so left drag click around, and then we're just going to drag this into the center of this black box with the yellow border. So now this is where we can actually start lining everything up and making it what we want. So I also like to go through, and all of these little textured bits is the pin number for Fusion. So we can just like highlight it and delete it, because otherwise this will show up on the board and that doesn't really make sense. So we can just go around, delete all of these, there's no point having them. The top number on here, so this one, J2, we can just double click on this, right finger click on this and go to properties. Once in properties, the bit that says name component is where we're going to write the name. So I'm just going to make this servo R. So that's my right servo. Now unfortunately you can't put any spaces, so it just has to be a jumble of letters, which kind of sucks, but it makes sense if you've written it. If not, it's fine. So I'm just going to go around and now allocate names to all of these parts, and make sure to also cross-reference with your schematic, because if you've wired something up to like the limiter switch but you accidentally took one of the cosplay eyes, it's going to then be a bit confusing when you try to wire it up. So just definitely jump between those two slides, which can be used at these top two tabs. So there's my schematic, and now here's my circuit diagram. Okay, so once we've got all of these named, we're now going to want to drag around all the parts so we can layer it out. I thought I'd grab one of my PCBs and just show you what I mean. So a lot of my things have all been just run down the side. Wait, let me see if I can focus this. Oh, there we go. So all of my parts are just run down the side, and then this board in the center is my Arduino Nano. So I like to just keep it like compact as much in. Obviously if you want to do a different design like this one, which I made for Copeland from Melbourne Iron Man, he needed it in his jaw. He needed his in his jaw, that way he didn't have to have it around his ears or the back, which I think is actually a really good idea. I'm kind of jealous of it, so screw you, Copeland. But you can really make it whatever pattern. If you need it to fit in the ear and you need to make it a circle, or if you need to, I don't know, put it up in the forehead with like around your servos and you make it around. Any possibility that you want your PCB to look like, you can actually do. So once we're in here, we can just left drag each part. So I think that I'm going to put the servos on this side, my power can go on this side, and then my eyes can go on these sides, and a switch. So up into this corner, into the modify section, we've got the rotate, which we're going to use quite a lot just to rotate all these pins around so that we can have it neat, run like that, and not down. So if you just click on it with a left click, it brings it around. So I found the best way to do this is actually put the pin circles closest to the board. That way that it makes your pins just a little bit neater. There's kind of no reason for it, it's just my preference. Obviously if you want it like that for some reason on a 45-degree angle, you can go for it. But for the sake of this, I'm just putting all the pins just close in the board. Don't question it. Okay, so once we've done all of this, we are going to just want to go and click escape. That just cancels us out of rotate. We can also move the names around. Can we? Yes. So if we wanted the name on opposite sides, we can, but I'm just going to pull them to the top so that they're not tucked under the PCB, because then they could be stuck under the Arduino Nano and then holes get drilled into them and you won't be able to read them. So I'm just going to move them all to the other side, just opposite sides of the parts. That way it's just easier once you're trying to assemble it. So once that's done, we can now just actually start lining everything up. So we can go relatively close actually. There's not too much fuss. Obviously if you want to put them all on one side and have one side empty, go for it. If you want to put them at the top, though, we could put them up here. We could rotate this and we could do the power up the top just so you exactly know where power is. But seeing that everything's labeled, we can really do what we want. Okay, so once you're happy with your design, so this is what I've created. I've just got the limiter switches and the power, both eyes, and then the servos on each side. So now we need to actually wire everything up. So this bit's kind of actually quite fun. It's a little bit confusing at sometimes, but I'll explain it the best I can. So up here into route, we're just going to click route manual. This way you can actually just do it yourself. I've never used, there is this feature somewhere where you can do it manually, but I don't know how to do that. So once you click route manual, you're going to be met with this bit. We really don't need to worry about anything on this side. We just need to be worried about this box. So this is top, and when we click on it, it's bottom. So this is where we can run the wires across the top of the PCB and the bottom of the PCB. So this way, if we needed wires on the top and they needed to run across each other, we'd need to run one on the top and one on the bottom. This way we don't have to worry about parts being intersected, and that way then we cause two negatives and a positive, or a signal into the negative. So I'm going to select top just to the start, and I'm going to first left click on this piece, and it will show you where it needs to go. That's all these highlighted parts. So as you can, so like these tend to be what do they call them? So these are actually our negatives. So anything with a number 1, it will let you connect to that because it's number 1, it's ground. So we're just going to run it down, and every time you want to left click, so if we select, I don't know, let's go number 2 here. If you click with your left mouse cursor thing, you can actually make the wires go in any direction. So we could do that, for example, but it's obviously a lot neater just doing that. So I'm also going to show an example of the negative. So where these two wires intersect each other, obviously we're not going to be able to run these both on the top. So we're going to need to run one underneath and one on the top. So I've run this first wire over the top, and we're going to then go to number 1 top and select 16 bottom. Now we can select this and go perfectly under. So that means that this first wire is on the top of the board and the second is under the board. This way nothing can be short-circuited or not work. So now that's all that's done, you kind of just have to go through each bit and just simply click and wire everything up and do your best to sort of jump around each part. Yeah, okay, so now that everything's been wired up, as you can see in my diagram, it's a little bit mess, but you're never going to actually see these wires. They're so small that they actually just embed into the board. You can see a very faint outline, but it doesn't matter because you're not going to ever see the board anyway. So now that this is done and we're actually happy with the layout, this is where the yellow border comes in. Now this yellow border is exactly how all of the PCB is going to be put together. So as you can see, I can manipulate it, make it a trapezoid, I think, is that's what you call it. And I can make the board look exactly like that. I could export it and then get it manufactured, but obviously that's not really going to fit in our helmet. So we're going to go to the next best thing and actually just make it a rectangle. So by just left finger hold clicking, pulling the thingy, just bring it down into the correct place, then let go, and now that's where it is. And then you can just bring all the sides in. Make sure to try and keep it as level as, because sometimes I found that I manufactured my first line of boards and they were just a little bit skew-if. It was very unnoticeable, but you just got to be careful with it. If you just try and keep it straight as possible, then you're all good. And there we go. That's the first bit done. Now that's our board. So anything in the grey around the outside will not be manufactured. It's just all the stuff in that little yellow border. Now obviously if you want to go ahead and we wanted to add, I don't know, let's say a curve to our board or a circle, we're going to want to go to this little bit, and it's called board shape. Now in here it gives you a couple options. A polyline, so we can make it straights and curves and squiggly lines or anything. Arc, if we just wanted to arc all our curves, just make them a little bit neater around the edges, or a circle. So for this I actually made a PCB that was a circle. So this is my arc reactor one. So this fits perfectly within my arc reactor. I even put an arc reactor piece on the back just for the looks, because it's kind of fun. So I was actually able to make a circle that fits perfectly in my arc reactor, and that way it wasn't like squared or anything and rattle around when I'm trying to walk in the suit. So for an example, if we need a circle, we're just going to take this and we're just going to drag and then click, and then when we're happy with it, we're just going to drag it over the top. Now obviously this is much smaller, and for some reason when we're trying to make the PCBs, right here it says mil, but it's not millimeters, it's mil something. So it's like 1 millimeter is like 0.02 of a mil. It's really confusing. Or I think you can even punch it in and put mm, and then it makes it. I don't know for American people if it works in inches or not. I don't work with inches because I'm an Australian. So yeah, just to play around with each measurement. Obviously measurements are all different in different countries, so just play around with it, see what works with you. You can really make your boards whatever you feel like. So just play around with the designs. They're quite simple. Just clicking and then dragging and all sorts of stuff. It just creates whatever you need. Oh, but that also reminds me. So if you get a bit that looks like this, and you can see how it's grey on the inside, but then black on this outside, that means that it's not going to actually manufacture this grey bit, but it's completely fine. We're just going to highlight these lines on the outside and just delete them. And now, problem solved. Okay, so now you've got the design you exactly want. We're going to add some nice little decals onto the back. Now, this isn't actually as confusing. It was a little bit hard for me at the start to try and figure this out, because no one's really actually given a good detailed video on how to make a custom PCB, but that's why I'm here. So for the sake of this video, I'm obviously doing it for Iron Man suits, as you can see, and Mando and all that random other stuff. But obviously this can be used for anything. So if you wanted the spaceship on the back, or if you wanted a Teletubby, go for it. But for this, I just like to put a thing that's designed for what my PCB was. So for my arc reactor, I put an arc reactor. For my helmet, I put a helmet. For anything, you just, whatever decal you want on it, you can kind of put on it. It's quite simple. So first we're going to, we want to go to Google. So in Google, we're just going to search for, let's say, Iron Man helmet. So we're just going to search for this, images. Obviously it's going to come up with a lot, so we probably want to put in stencil. So when we get a stencil, we're just going to have a look. So look for whatever stencil you feel like you like, or the other thing you tend to put in is silhouette, which is a weird spelling. Silhouette actually gives you better options. Just play around, because each thing I've searched for, it works between stencil or silhouette. It really depends on what you want. So let's go with this one. I like the look of this helmet. Kind of looks a bit cool. It's a helmet from Iron Man. Alright. So we're just going to drag and drop that onto our desktop. And so I'm using a Windows computer. So I'm going to open Microsoft Paint. There are ways you can do this for Apple if you're on a Mac. I'm not too sure, I've never learnt it, but you just want to basically figure out how to turn a PNG into a BWT bitmap. I think you can probably, there's converters online if you needed those, but I'm just going to show it the Windows way, because I'm sorry, it's the only way I know. So once we're into Paint, we're going to select File and Open. So here's our part, we're just going to open this, and now we've got our part. So this is the exact way I want it. For this helmet is symmetric, so if something isn't symmetric, you wanted it on like the base of your PCB, you're going to need to flip it, and you have to actually do this before importing into Fusion. So say for this PCB that I made, I needed to actually flip it first before I import it into Fusion, because you actually can't flip it. It's a little bit annoying, but you kind of get the hang of it slowly. For this one, it's fine, we don't need to flip it, but if you need to flip it, options are here. So we're going to go File, and we're going to go Save As other format, sorry. And we're going to select Type and select Monochrome Bitmap. This is just meaning it's black and white, there's no colors involved. This is the way that they register it, and you can kind of only have one option when you make the PCB, so there isn't multitude. And we're just going to go Save and just OK. So once we're back into Fusion, we can now search into Automation. This is where you're going to go first, and to ULP. So once you're into ULP, you can search for Import. Now Import gives you some options, but we're just going to select which one is this first one? It's called Import BMP. And we're just going to select OK, and OK again. Now this gives you access to your computer where you're going to find where exactly you saved it, which I'm pretty sure this is the one. This is our bitmap. So just select it, open. Now you'll be met with these two because we saved it as monochrome, so that is black and white. We're just going to select black because it's kind of the only option we need, because we don't need it multiple colors. And we're just going to select OK. In here we can search it into the correct units, so inches, millimeters, and micron. Don't know what that is. It also does tell you how many pixels it is, but I don't tend to use that. I don't really understand how big my PCB is in pixels, but this is the main number you want to focus on. So this is valued at 1 at the moment. Just import it and OK. Now this is obviously all going to import into different sizes. So you can see in this bottom corner we've got our bitmap. Now it's a little bit small for what I'd like, because you can see it only just really fits at the bottom of the nano. So if you want it bigger, unfortunately you have to delete it, and also make sure to watch out for this. This imports at the bottom in every logo, and it's telling you exactly where it came from on your PCB, on your PC, not your PCB, which obviously you don't want located on your board somewhere, so just make sure to delete that. I found that some images tend to not even come with one, or I've just never seen them, but do be aware of those. So now that this wasn't the correct size, we have to go back to the ULP and then select it again, monochrome, and now back to this screen. So once we're back in, let's punch in like 5. Now this is the most tedious bit of making a PCB, I find, because you can't actually scale it. So once it's in, you have to delete it and restart it. So obviously we're just going to put in, let's try 5. Let's see what this comes with. Now this is massive, so we have to go back again, and let's go 3. There we go, that's much better. Alright, so once this is in, you want to highlight all the parts so that we don't miss little bits, because each little bit is made up by a little pixel, as you can see. If we delete one of those, it's probably going to look a bit funny. So once we've highlighted it, just drag it over to where we want it. So I'm just going to put this bang smack in the PCB. So this gives you every variable that's in your bitmap. So obviously the more detail it is, the more numbers you're going to have. But we just need to be worried about this bit. Bit is where you're going to be able to put your, what do they call it? They call it a silk skin, I think, onto our PCB. So just scroll all the way to the top, and we just want to be worried about silk screen bottom and silk screen top. Now if you want it on the top of the PCB, so if you want something like this, so I put my username, my Instagram, Create Extrusion, onto the PCB, so that's the top of my PCB, whereas when I did the arc reactor on the back, this was the silkscreen bottom. So it really depends where you want it. For this sake, it's kind of, all my electronics are on the top of my PCB, so when all the electronics are on top, you're actually never going to be able to see them really. So I'm just going to select the bottom, and that way it's going to go on the bottom of the PCB, so all the electronics will be on top and the image will be at the bottom. So now we can just select off it, and there we go, it's in the PCB. And so if you want to go across and, you know, plus your Instagram or your name, or you wanted to put Iron Man rocks or something like that at the bottom, just type it up. I tend to find that using a place called FontSpace is where I tend to get all my fonts. It's just a free website where you can download fonts of any type, shape, color, and I just tend to like it. That's where I originally got my font from my Instagram. And then you can just import the exact same principles into Paint, exporting as a monochrome bitmap, uploading into Fusion, scale it to what you need, and then import it. Okay, so now that we're happy with the way our PCB looks, we want to go over to here. So this is push to 3D PCB, and we're just going to click push. So some of these electronics actually don't have components to them, but once it's loaded, it allows us to actually see our model in 3D, which is quite cool. So here's our Arduino Nano, our power, the eyes, servo right, servo left, and our switch. And if we flip to the bottom, big Iron Man helmet. So this way you can just see your PCB visually. If you can't like the way that everything's been allocated, you can just jump back to the previous slide through the tabs at the top, fix it up. So say I want this border in a bit, and I want this border in to about there. It will notify you that it's out of sync, but you just click push to 3D PCB, push, and then it updates everything again. So once you're happy with it, now it's time to manufacture the PCB. So we're nearly finished in the PCB. I did forget one thing. So when we're trying to attach the PCB, we're going to need to be able to somehow mount it to what we need. So that's where we're going to make these little circle cuts, these little drill holes, so you can see right there. So this allows us to put in a screw or a bolt or some sort that we can mount it to the side of our piece, like a part. So for me, when I did one of my other parts, my leg PCB, I made 2 holes at the top, 2 holes at the bottom, and that way now I have a mounting bracket that I'd 3D designed and printed. I can now just locate it straight in and screw it in. So this is actually relatively easy. We're just going to go to design and here to hole. Once you click on hole, we can just allocate where we want them. So I'm going to put them in all 4 corners. Now you will notice that these holes are really small because it's been set to 13 mil, not millimeters, MIL again. So we're just going to highlight it and click 33 mil. 3 mil tends to be a typical size for these, and there we go. So we're just going to go back around all of these and type in 3 mil. Obviously if you want these in a different unit, go for it. As I'm an Australian, I'm just going with 3 millimeters. So once all these parts are in, you can see that they're starting to overlap over where our JST connectors are going to be. So seeing that these are now all shoved into the corners as much as they physically can go, we can actually move them around as well. So if you wanted them elsewhere, go for it. I'm just going to push them as far as I can up into the corner just for the ease. So we're just going to have to move some parts around just to make sure everything's going to fit. Now the wires are attached to the parts, so don't worry about the wires detaching. The wires are all going to be completely fine. So we're just going to pull these until they're not hit. Just to double check that we're happy with everything, we're just going to push to 3D, let it load, and there we go. So now we've got some holes that we can now mount our PCBs to the side of our wall, like a helmet, or to the side of the wall, or for your leg, or something like that. Now that we're happy to export this and get it ready for manufacturing, we're just going to go to the manufacturing tab and this third option here, export Gerber drill file stuff. So we're going to click on this, don't worry about any of this, it's all nonsense, and we're just going to name this helmet PCB and save. So now it's on our desktop, ready to go. So just when you get to your desktop, here's our PCB file that we're going to need. We're also just going to create a new folder. So we're going to need a folder to actually upload this to PCBWay. I found that the best way is just making a second folder instead of trying to delete stuff in the other folder we've just exported. This is personal preferences, just makes my life easier. So we're going to name this folder helmet PCBWay. And that way we know exactly what we need. So we're going to extract all the files from this folder so we can get access to them. So we'll bring this folder back over, open it up, click on CAM outputs. Now there's assembly, drill files and Gerber files. So the Gerber files is all the stuff with the wiring, our names, the silk screen, so our helmet on the back. Then there's the drill files. So this is where all of the little holes for like the Arduino Nano, it's all running across down the back. Our drill holes that we just made, so the top corner oneys. So what I found works best is click on the drill file and just drag and drop it into Gerber files. This way when they open it, they've got all of the stuff they need plus the drill files. And then I drag and drop the Gerber files onto my desktop. I'll take these Gerber files and put them into our new helmet folder that we've just made, which then we're going to click on and we're going to compress to zip file, because PCB needs this as a zip file, not as any other option. So now that we've got our little option over here, we're going to go to Google and search for PCBWay. Okay, so we're going to open up into PCBWay in whatever search engine you feel like. And this is where we now have to pick our colors, the way that everything wants, how many we need, and our sizing. So you actually need to leave Fusion open, so don't forget to leave it open. And we're going to want to jump over to our 3D view. So in here we've got the option to measure. So we're going to need to measure this just so that PCBWay has a rough estimation of how big they need it. So if we just click on whatever angle we want, we can see that this one's located at 47 mil. I'm going to jump back and put in 48 just to round it up, it makes it easier. And then we can see the opposite side is 37.3, so I'm just going to round it down to 37. This doesn't actually matter. I found I've put in random measurements that are relatively close but not spot on. There's never been a problem so far. So we're just going to put in 37. Now the number of PCBs, obviously if this is your first time making one, I would recommend just going with 5. That's the smallest option you get. I have gone through and made PCBs before that were all with AT-Tiny85s and they didn't work. So just steer clear of AT-Tiny85s, I suppose. But do double check all your wiring before you upload it. I'm pretty confident with how mine is, but every time that I've got a PCB, I tend to just go through, double check everything's been wired correctly. Obviously if something has been put into the wrong pin, you just code it differently and just put in the different pin for that you allocated it to. But obviously if you've got negatives going to positives and positives going into the board wrong, you definitely want to save them before you buy the board and get it shipped to you and then it doesn't work. And then we're going to need 2 layers because we've got our top and our bottom, and the thickness is 1.6. So we're just going to quote this. The quotes all tend to be about the exact same. I believe this conversion is in US, so be careful with that. So we don't really need too much, we can just keep scrolling down until we hit solder mask. So this is where we get to pick the color. I tend to just pick black just because it's super simple, it looks really nice. But obviously you can pick red, yellow, green, blue, white. I would steer clear of white personally. As you can see in this photo, they tend to, like, if you try to solder and you solder it wrong, it burns the white. It just leaves like a little odd looking mess. I don't really like it, but obviously if you do, go for it. When you hit purple, you will notice that the price jumps significantly, which kind of sucks because like purple PCBs would be cool. And that's the same with the matte black and the matte green, but black, white, blue, yellow and red and green are all the same price. And we're going to select a white mask, so that is the white writing our white drawings, and that's easy enough. And then we're just going to calculate, and then we go. So we're just going to save this to our cart. You agree. So then we're going to be met with this screen, add Gerber files. So that's the files that we just made into our custom zip folder. So you're going to select Gerber file, go to my desktop, and it's this one, Helmet PCB Way. We're just going to double click it, let it upload and submit. So now that is sitting here ready to go. Now somebody's actually going to review this and see if it's going to work with their machines. They will let you know if something's wrong. They also do have a live chat just in case you don't understand something. I have used that before because I don't understand some stuff. So we're just going to wait now until they reply to us and say, hey, this PCB is all good to go. Right, so Future Me is back and the PCB has been approved. So now you can go ahead, purchase these, or when they arrive, wire them up, and then you've just made your first custom PCB. I really hope this video helped a couple of you out on actually how to do this. There's not that many videos out there on actually how to make a custom PCB. Fingers crossed for my first YouTube video, this wasn't actually as horrible as I thought it would have been. But if you've got any comments, questions or concerns, please leave them down below. I'm going to try my best and actually try and read these comments. I don't know how well that will go. But yes, thank you so much for watching and you have a good day.